Today's class is strain transformation. So it's built on the stress transformation that we learned in the previous lesson. Before we go to strain transformation, I just want to have a review. What is strain? So talk about strain. So where at the stress, we have normal stress and shear stress. Similar for strain, we also have normal strain and shear strain. And I hope you remember what is that about. So let's talk about normal strain. If we have 2D X and Y, if we have a block, then the normal strain in 2D in X direction, we have it epsilon X, and of course there is epsilon S on the other side. In Y direction, we have epsilon Y, and turn down with the epsilon Y. So that in normal strain, similar to the normal stress that we have. And then we also have shear strain. Shear strain. So shear strain measure the angular distortion of structural members. So if we have it also in X and Y direction, if we have a block, angular distortion, then we have the shear strain gamma, then we have gamma in the Y plane. So we have that gamma is gamma xy, same as tau xy that we are talking about. So that is strains. The change in length, measure that is normal strain, and the angular distortion, that is shear strain. What are the equation we already learned previously in this class, and now we don't want to repeat that. You can see the stress transformation is very long lessons with cover many topics, and we don't want to go over that again. To avoid going over again with the long process, we want to emphasize the analogies of stress and strain transformation. So let's write down here. We have the stress and strains analogy. So when we master with these analogies, the process is become very simple. So in the stress transformation, as you can see, we have original coordinate X and Y, and that is given sigma X, sigma Y, and tau XY. We want to know what is the sigma, normal stress, and shear stress if we rotate the plane angle theta from the original plane. So for example here, the angle theta move in that direction, in this case counterclockwise. So we have X apostrophe and Y apostrophe. So what are the sigma X apostrophe, sigma Y apostrophe, and also tau X apostrophe, Y apostrophe. So that's the purpose of the transformation in stress. In strain, it will be the same. Then how we can utilize the process that we did in the previous lesson to here. So that the analogy is all about. If we talking about the sigma in the previous lesson in the stress transformation, then here equivalent to the epsilon. So that is the analogy we are talking about. And then if we talk about in the previous lesson in tau, the shear stress, then the analogy in today's lesson, strength transformation, that is gamma, but not gamma, but it will be half gamma. It's gamma, but it's half gamma. So whatever equation we learn in stress transformation, we just replace epsilon for sigma, gamma over 2 for tau. Then we get exactly the same equation that we go over in a minute. So let me give a few notes here before we continue with the equation. So the transformation, let's put it down here, as you can see. With that analogy, we say that the transformation of tensor similar to vector, but that is in 3D. So we just make a general case, we call it tensor, but normally we deal with the vector or tensor is 3D. Okay, so with that we have same as for both sigma and epsilon. So it means same stress and strain. The transformation of those tensor that we just learned, it will be similar. And also apply for the more circles, because more circles is a representation of the tensor of a tensor. So a state of stress, then it can also represent the state of strain. So with that we can say, since more circle is a representation of tensor. Then it also analogous. It is also analogous. So how to develop the center, how to determine the radius and the side convention, it will be analogous for strain. So with that, we want to go to the strain transformation equation that we utilize from the previous lesson. So let's put down here. So what can we do with the strain transformation equation? So sin epsilon same as sigma, gamma over 2 same as tau. So we can have that the same. So let's go back to here to review. In the previous lesson, in the summary, as you can see, equation for sigma x apostrophe, it equal to sigma x plus sigma y over 2, and then plus all of that components, tau x apostrophe y apostrophe. The principal stress equations, we also have that for sigma. The maximum in-plane shear stress equation, tau max, is have that equation. So we just replace sigma with epsilon and tau with gamma over 2. Then we have equation for strain. So with that, here we can have that epsilon x apostrophe equal to epsilon x plus epsilon y over 2 plus epsilon x minus epsilon y over 2 cosine 2 theta plus, instead of tau, then we have gamma x y over 2. That's the difference, because the analogy is tau now gamma over 2. Keep that in mind. sine 2 theta. So that is for epsilon x apostrophe. The tau xy, now it replaced with the gamma x apostrophe y apostrophe over 2. Half, everything it become half for the gamma. So it equal to the equation now, the same, gamma x minus gamma y over 2 sine 2 theta plus tau xy, in this case replace with gamma xy over 2 cosine 2 theta. So that equation for strain transformation based on the stress transformation with the analogy that we just talking about in here. Similarly, we also have the principal strain equation. At the principal stress, right? So we also have principal strength. So in there we have sigma 1, sigma 2. Now we have epsilon 1, epsilon 2. So epsilon 1 and epsilon 2 is equal to epsilon x plus epsilon y over 2 plus or minus, depends on epsilon 1 or epsilon 2 we are talking about, epsilon x minus epsilon y over 2 square plus tau xy, now it become gamma over 2 gamma xy over 2 square. And also, as you can see, that actually equal to epsilon average, and you can see that, plus or minus gamma max over 2, because of tau max, now gamma max over 2. So from that we can box all of this equation here. Equation we can box. So with that analogy, we can see the equation become more straightforward. And also we have maximum in-plane stress. So it tau max, now it become gamma max over 2 is equal to square root of epsilon x minus epsilon y over 2 square plus gamma xy over 2 for tau max become over 2 for gamma. So from that we also have gamma max over 2. So to find out gamma max, you need to times 2 kick up there. So we have that equation. So as you can see, it took very long to get all of this equation in the stress transformation. But with the analogies, we can be able to find out that equation very quickly for the stress transformation equation. In the next video, we will talking about the Mohr circle and how to solve it for strain and strain process.